Hi, my name is Bianca Marcelletti, and today I will be analyzing detection techniques for the Burmese python. The Burmese python is native to Southeast Asia, and they were introduced to Florida in the 20th century via the pet trade. They pose a large threat to Floridian wildlife because they can aggressively predate a wide range of vertebrates, and detecting pythons in the field has proven to be difficult because of the snake's cryptic coloration and because they are well adapted to Florida's wetlands. So for this project, I will discuss 3 detection techniques, which are visual surveys, trapping, and environmental DNA, to determine which of the 3 is most effective at detecting pythons. To start off, visual surveys entail walking along transects or searching an area for visible pythons. If pythons are visually detected, they can be captured, tagged, and used for future experimentation, and visual surveys also require only a few materials to be conducted. However, there are several downsides to visual surveys, namely that detection probability is very, very low because these animals can camouflage into the habitat so well. Surveys are also time-consuming, costly, and require many people to cover large portions of land, and it is necessary to have lots of experienced surveyors for these visual surveys to be effective. Additionally, because Burmese pythons occupy wetlands, much of their habitat can be inaccessible due to water-dense vegetation. For trapping Burmese pythons, funnel traps are typically used. These traps include bait and prevent the snake from exiting once it has entered the trap. Like visual surveys, trap pythons can be tagged and used in future experimentation. However, non-target animals may also enter the trap and subsequently be eaten by the snakes. And also, like the surveys, they have a very, very low detection or capture rate, especially if there is abundant prey in the area or if the snakes are unable to locate the entrance of the trap. For environmental DNA or eDNA, water samples from Burmese python habitat are collected and tested for traces of DNA that have been shed from the snake and into the environment. Unlike visual surveys and trapping, eDNA has a very high detection and accuracy rate, and DNA can be detected in water samples from the snakes up to 4 days after being shed. Additionally, eDNA can be used to determine the current python range in Florida and monitor any future expansion of that range. However, eDNA is not perfect, and it can only detect python presence and cannot distinguish between individual pythons. So it can't really be used to capture pythons or conduct any accurate population estimates on the pythons. Additionally, eDNA is spread heterogeneously throughout an area, so water samples from the same area can have different results. One sample may say that pythons are absent simply because there isn't any DNA in that sample, while another sample may say that the pythons are present in the area. To conclude, future research into Burmese pythons should utilize eDNA because of its high detection probability and cost effectiveness compared to visual surveys and trapping. To maximize eDNA's utility, numerous large water samples should be collected from an area, and eDNA can also be used to determine which areas pythons occupy and narrow the area that needs to be searched in the visual survey or the area that traps need to be set up in. To improve visual surveys, if you want to couple visual surveys with eDNA, areas should be surveyed during conditions that attract out pythons like temperate sunny days or warm nights.